Hello and welcome. This is the masterclass about decentralized identity protocols and standards. My name's Chris Eckl. I'm CTO of Condatis, and with me today is Richard.
Hi folks, I'm Richard Astley, Lead Solutions Architect. Welcome all today.
Together we'll lead you through today's masterclass.
So today's masterclass on decentralized identity protocols and standards, masterclass 3 in 7 masterclasses. All the other masterclasses are going to be available on INTEROPen's YouTube channel, and there's more information about the hackathon and masterclasses available at interopen.river.com.
We split today's masterclass into 4 parts. We want to talk about verifiable credentials, DIDs, and then 2 implementations, one Hyperledger Aries and one self-issued OpenID provider. So let's get started. So Richard, what is a verifiable credential? Could you talk us through that?
Yeah, Chris, a verifiable credential, it's a data model that's been created by the World Wide Web Consortium. So a verifiable credential is a data model that provides a mechanism to express credentials on the web in a way that's cryptographically secure, privacy respecting, and machine verifiable. So a verifiable credential can represent the same information that a physical credential represents, but with addition of technologies such as digital signatures, makes verifiable credentials more tamper evident and more trustworthy than their physical counterparts.
So is it really like a passport I have in my pocket, but in an online version?
That's exactly. So just in the same way your passport is tamper evident by watermarking, using holograms and other security techniques on a physical document, a verifiable credential has cryptographic tamper proofing also applied to it. So this is how it's more trustworthy than the physical counterparts.
So let's look into the model of how those verifiable credentials are used in the real world. So verifiable credentials have an ecosystem in that they live. And the holder is the digital wallet that has a verifiable credential inside. And the verifiable credential itself expresses information about a subject. Those verifiable credentials are issued, a bit like your passport, by an issuer. So the government that issues your passport is the issuer. And issuing, the government is actually putting their signature around the information about yourself. On the other side, the verifier is the people who need information about the subject and need to verify the authenticity of that information. And so a bit like the border control who validates your passport. And to enable that validation, there's a verifiable data registry, could be a blockchain or a distributed ledger or some other private database even. And that registry allows the issuer to register their signatures, their public keys that they use to issue verifiable credential, and allow the verifier to look up those public keys and therefore be able to authenticate the credential and validate it. So, Richard, you said a verifiable credential is a data model. Can you talk about this data model?
Yeah, a verifiable credential, it's just a data model that's made up of a few different parts, really. We can define the model as having 3 main areas. We have the metadata that's really describing the properties of the credential. We've got things like the identifiers and the type of credential or presentation. We've got information that deals with when it was issued and when it expires. How we go about validating that model using the credential schema, even how the credential can be refreshed and validated. We've then got the claims, and this is really the claims the issuer is making about a subject. And then we have the proof mechanism. So this is the cryptographic proof that's normally in the form of a signature that signs the rest of the credential and ensures it is from the issuer that has issued the credential.
So using a verifiable credential, and we spoke about those different entities like a verifier who wants some information about your verifiable credential. Using the verifiable credential is actually done by a presentation. So a verifiable credential is never transmitted to the verifier, but a presentation about it is sent to the verifier. And it's packaged in a way so the verifier can validate the authorship and the authenticity. Again, this presentation has our own proofing mechanism. So we create a proof that fulfills the presentation, and that proof has our own cryptographic proofing mechanism that allows the verifier to clearly authenticate the presentation of that verifiable credential, and that the holder legitimately holds that credential.
Thanks, Chris. I think this concept of presentations is really good, especially when we look at presentations using derived credentials such as zero-knowledge proofs. So a zero-knowledge proof is a cryptographic method where an entity can prove to another entity that it knows a certain value without actually disclosing the value. So even if a verifiable presentation shares all of the claims within a verifiable credential, it might not actually identify the credential itself in the presentation. So zero-knowledge proofs are really useful because they allow the holder to combine multiple verifiable credentials from multiple issuers into a single verifiable presentation without revealing the verifiable credential of subject identifiers to the verifier. So you can selectively disclose claims in a verifiable credential to a verifier and only provide the information the verifier needs and nothing more. So if you think of the scenario of sharing your driver's license in person, you disclose a lot of information just for somebody to simply check your date of birth. By selectively disclosing information, we restrict it to data that only the verifier needs.
So it really protects your privacy and protects you from oversharing, doesn't it? You know, why does a corner shop need to know your address just for you to buy a bottle of beer? There's other good use cases, of course. You know, in real life, we overshare in a lot of ways, in a lot of situations, you know, by using our passport or driving license in situations that's not really appropriate to use this, just for an age proof, just for I am a citizen of this country. Why does the verifier in this case need to have all this information? So zero knowledge proofs are a way of enabling this minimal disclosure that isn't easy in the real world, because in the real world you always need to go back to, well, how do I know that this is your proof of age? And that's one of the beauties of verifiable credential and the cryptographic, that we can prove this through this chain of issuer, holder, subject to verifier. Let's talk about the life of a verifiable credential maybe, and those different ways of using it and how often it is used. So what can happen with a verifiable credential?
So really a verifiable credential starts off its life with the issuer. The issuer wants to assert a claim about some subject and issue it to some sort of holder. So an issuer will create a verifiable credential with a set of claims. He'll issue it to the holder. The holder will keep this in their wallet. And the holder's got a few options here. They can just delete a credential anytime they like. They can transfer that credential to another holder.
A good use case for that is delegation, for example. I can't pick up my order myself. I can delegate this to somebody else.
So a holder will transfer or present a credential to a verifier wants to know some sort of information about the holder of subject, so they'll ask to share this verifiable credential, and the holder will be able to create a verifiable presentation and share this with the verifier. The verifier needs to check the authenticity and status of the credentials to make sure that the credential's not been revoked. An issuer can revoke a verifiable credential at any time, so they can either write this to the registry, so when a verifier makes a check against the registry, it'll show that that's no longer valid and it's been revoked, or the issuer can actually host their own check status endpoint, where a verifier can call directly to the issuer. So that causes a few concerns, or supports a few different business models. I don't know if you've got thoughts on the difference between those, Chris.
Well, thanks, Richard. Yeah. So the interesting challenge there obviously is, if I turn somewhere up and my credential looks valid, but the issuer has had second thoughts by now and either wants to upgrade or take away the verifiable credential from me. So taking away, yeah, we talked about they can revoke it, and that's a public action. It's on the registry. And when a verifier checks or verifies, it will just not verify because they check a revoke register and it's marked as revoked, and therefore it's not good anymore. The other way of a status is that there's actually a relationship between the verifier and the issuer. So when I present my presentation to a verifier, the verifier sees that this presentation is by a certain issuer, and there's actually a status check embedded in the presentation that allows the verifier to check the live status of this at the issuer. Now, the main challenge with this is the privacy preservation for the holder, because that means that every time the holder presents a verifiable credential or its presentation, the verifier has the right to go to the issuer, and therefore the issuer knows every time you use your verifiable credential. Now, that might be okay in certain circumstances, but in other circumstances, we are trying to get away from an almighty issuer who knows every time I use any of my credentials, because currently, for example, the government doesn't know when you use your passport to verify your age. In this case, the verifier would call back. Now, that's one thing, privacy preservation is out of the window with such a status check. On the other hand, there might be a business model where the issuer spends money to give you a verifiable credential. So there's a business model for the issuer to actually charge the verifiers or charge the holders every time a credential is used. So it's like an entitlement that has a callback mechanism and a chargeback mechanism, and maybe the business model is formulated in such a frame that the verifier only can take assurance that this presentation is good for them and can take a liability shift if they check the status with the issuer and maybe pay some money. And that payment of money or that issuer check allows a business model of transferring liability. So yes and no. No, it could be good to have this direct relationship between issuer and verifier for certain business model, but normally we are trying to abstract it. And if there's something wrong, maybe revocation is the better way to do this.
Yeah, I can certainly see it supports both models quite well. By using the registry, you can have no tracking on any of the verifications that are being done. But if there's a business model of some governance model where a verifier has to contact directly with the issuer, then it also supports that scenario. Thanks, Chris.
So I hope this gave an introduction to the verifiable credentials. Shall we go to the next section?
Yeah, so the next section we want to talk about is DIDs. What is a DID, Chris?
So a DID is really a decentralized identifier, and they're created in a W3C standard again, and they are identifiers that allow me to make an identifier for myself and encapsulate everything that's needed to know about this identifier, including that I can prove control over it, how to communicate about it, what my keys are, all in one identifier that is subject identifier for myself. So a DID contains a document that expresses the crypto around my identity, what verification method I have, what service endpoints I expose to allow another entity to communicate with me, and also how I can show the world how I control my DID. So the DID document shows way of cryptographically authenticating to assert the control and show others how they communicate with me. So how does a DID look like?
DIDs are really just a simple text string that contains a URL schema identifier of DID. It's got an identifier for the DID method. So you see the method here of example, and then it's got a method-specific identifier that's generated by a DID method. It's also got a DID subject. So the DID subject really is the entity that's been identified by the DID. So this can be people, it can be things, it can be anything really that the DID chooses. So we've got a few other things. We've got the DID controller. So the DID controller is really the person or entity that's allowed to change a DID document. So they're generally the holder of the keys that have been used to produce the DID document. We've also got a verifiable data registry. The verifiable data registry, this is where all the records of the DIDs get kept. And this is what allows them to be exposed over the internet and discoverable.
That allows really somebody to resolve a DID identity, as you had there with your text string, to a DID document, doesn't it?
That's right, yeah. So that's the job of the DID resolver. So the DID resolver will take the URL schema that you see there, and it'll actually resolve it to a DID document with its metadata, the verification methods and services. So we've got these DID resolvers that, as we spoke about, it takes a DID and it'll actually just resolve it against a DID document. There's also another concept which is DID dereferencing, and similar to DID resolvers, this will take a DID and it'll actually produce a resource out of it rather than just a DID document. So this can be things like public keys, the actual service endpoints, and various other resources within the DID.
I guess we should explain a bit more the items that are within that document. Verification methods express the cryptographic keys and the method of how to use them and how they're associated to subject and claims, and also allows the whole ability of rotating keys. And then there's a section around the actual public keys. So all the keys I use currently and I have used in the past. So there is some longevity also built in. And with the verification method and the combination of that, I can reference a lot of different keys that I'm using to assert information about myself.
One of the primary purposes of a DID document was to enable discovery of service endpoints. So a service endpoint can be any type of service the DID subject wants to advertise, including decentralized identity management services for further discovery, authentication, authorization, or interaction, such as getting verifiable credentials.
And the methods that you mentioned earlier, that comes after did colon is really there. So if two dids are exchanged, you can actually have interoperability between different systems. So not everybody needs to sit on the same data registry. People could be on different data registry. And later in the masterclass, we are talking about two different examples. One is the Hyperledger Aries, is expressed as did colon sov for sovereign, and the other a good implementation of the self-issued OpenID provider is the Microsoft implementation, which is on did colon ion. So the method really allows different registries to have their own methods and extend a standard set of methods and controlling actions with their specific technology that's needed for their registry. Okay, so next item on the agenda is talking about some of the implementation of SSI and the standards underlying those. So the one, Hyperledger Aries. Richard, do you want to take us through what Hyperledger Aries is based on?
Hyperledger Aries it's a community-based standard that many people have actually worked on to develop. And really it's an interoperability toolkit that's been designed to help in creating, transmitting and storing credentials. So it uses a distributed ledger technology, and it's really all about enabling peer-to-peer or agent-to-agent interactions. Aries is really an advancement that's built on top of all the work that Hyperledger Indy did. And the difference between Aries and Indy is really Indy was created for a specific blockchain, but the idea behind Aries is they're trying to make it blockchain agnostic.
And when we talk about those agents, what we really mean is that every actor within the system, whether that's an issuer or a holder or a verifier, is represented by an agent that interacts with another of those actors. And there can also be intermediary agents, like we see in this diagram here, like a consumer wallet could have a consumer cloud agent that holds messages until the wallet is available again, because there could be offline situations, similar in an enterprise situation where you have an enterprise agent and an enterprise cloud agent. And agents have three characteristics, really. It acts on behalf of an identity owner. So even the cloud agent is an on behalf agent, doesn't decrypt the message, but hands it on and acts in a secure protocol as all the other communications. And each agent has its own cryptographic keys, has private keys that identifies the agent and allows it to do its actions in a cryptographic way securely, and interact with this DITCOM protocols that we'll go in now. So DITCOM is the underlying protocol level of Hyperledger Aries, and it's like the communication protocol. So we had talked about verifiable credentials and presentations and how we request proofs. So DITCOM in Hyperledger Aries is a protocol implementation and a standard that allows that communication between agents. So there's software, and DITCOM is the communication between one agent and the other agent. DITCOM can happen over quite a number of different transport protocols like HTTP 1 or 2, WebSockets, IRQ, Bluetooth. There's Signal, that different ways of communicating. The protocols, the secure standard DITCOM, it is abstracted from the transport protocol, so it can use different transport protocols. DITCOM really allows agents to connect to each other, so exchange the initial keys. We learned earlier about DITs and DIT documents, in effect a DID document, if I exchange my DID document with another party, that really is all the information the other party needs to have to speak to me. So it contains my public keys, it contains my endpoints, it contains my methods, as we heard earlier. DIDCOM is the way of exchanging a secure way those DID documents with another party, with another agent. And exchanging, how do I talk to each other? What protocols do I support? Over DIDCOM, I can ask for credentials, get credentials issued. I can ask for proofs, get presentations issued. That's where DIDCOM comes in.
So it's really the secure connection that allows all agents to talk to each other.
And Hyperledger Aries, as Rich said, it's a community effort that came together, and a lot of companies input into it and make sure that it's built on, it's extended as the need arises. The main commercial implementation, I guess, is evident with Verity, Trinsics in there, IBM's using it, and you see that there's quite a number of frameworks that one can use and build own agents as well. So there's agent frameworks that you can just use to build own agents. Those are the main agents. So Connect Me, we are using in the hackathon as the mobile consumer wallet. It's an agent on the Hyperledger Aries. Verity is one of the enterprise agents we are using in the hackathon to issue credentials and to also verify it within an NHS concept. So we're using that as well.
Thanks, Chris. I think the next section that we're going to look at is really about SIOP and what SIOP is. So SIOP, or self-issued OpenID providers, is part of the OpenID Connect core specification. And it's really about being able to be your own OpenID provider and self-issue credentials. And so it's all about messaging as well. OpenID supports messaging between agents, and SIOP's been brought into the mix to allow verifiable credentials to be issued using the OpenID Connect standard.
We know OpenID already for a long time as a very modern approach to authentication and identity, and most identity systems go towards OpenID Connect. So OpenID Connect is well regarded in industry. It has had loads of security review. It's well established. It's not as old as SAML, but it is quite old by now, and therefore being well adopted had a lot of refinement in there. And OpenID already in the core specification of version 1 had this self-issued section in there that not a lot of people were paying attention to, but really it was forward-thinking of certain individuals that were going already towards the self-sovereign identity selection. So OpenID Connect is the one protocol that Microsoft has selected as their implementation for self-sovereign identity. They call it their DID services, so distributed identity, a synonym of the self-sovereign identity. A link to the website is here of the preview of the implementation. And Microsoft, building on the existing OpenID Connect standard, have chosen a different ledger to underline, to have this DID registry that we talked about earlier. And Richard, do you want to talk about the ledger technology they're using?
Yeah, sure. So Microsoft have actually gone with Bitcoin as the ledger system, but they don't just use Bitcoin directly because it can be expensive and very slow to write to. So they've actually developed a few other protocols, really. One of them's SideTree, and one of them's the Identity Overlay Network, or ION. And what this really is still decentralized identifiers and locating public keys and checking DID documents to make sure the holders do actually own them and where to go to validate a DID. So it's all the same technology, but they've used SideTree and ION together to really reduce the number of writes that are required to the main Bitcoin ledger. What it is it's blockchain agnostic, so it allows you to really write a mini ledger and build up many different operations into this smaller ledger system. And once you have a batch of these available, only at that point it'll actually start writing to the Bitcoin ledger.
So you were saying Bitcoin is slow to write to and expensive to write to. So it's really an abstraction.
That's right, yeah. So it creates this other layer. So lots of much smaller ledgers that will be written to rather than going directly to the Bitcoin ledger. And periodically, it will write and calculate the hashes used in Bitcoin. But by doing it incrementally in batches, it reduces the number of times Bitcoin ledger has to actually calculate the new hashes. So you'll get a real performance and cost saving by using Sidetree and Ion.
So Sidetree is the protocol to have Hyperledger, and Ion is their implementation to Bitcoin. So that means they now have a framework to have a ledger as well, have a well-known underlying ledger, where Hyperledger Aries did come as a messaging protocol. You know, Microsoft uses this OpenID Connect self-issued provider. And by using this self-issued provider, they actually have available already the whole infrastructure of OpenID Connect relying parties that can now just start consuming identities from SSI wallets. Now, one of the challenges is with OpenID Connect that usually you have a trust relationship between the identity providers and the relying parties, and relying parties are trust the identity providers. But with the identity provider being myself or my wallet, the challenge we have with OpenID Connect is a registration of the identity provider, because the wallets can be Richard's wallet, my wallet, anybody's wallet. And in OpenID Connect, you have this concept of a relying party being tightly reliant and trusting an identity provider. But how can they trust any wallet that comes along? So in OpenID Connect, the specification, there is a section around self-registration and a standard around self-registration. And self-registration wasn't used until SSI came along. Self-registration is very useful for SSI because, in effect, any wallet can come along to a relying party and say, hey, I'm a wallet, just trust me, because the trust is not built up on a pre-registration between a relying party and an identity provider. The trust is based on what I will give you. So when I present my verifiable credential, my presentation of the verifiable credential to the relying party can, based on the crypto and all the data model we heard about the verifiable credential, build trust in that only I could have issued this attribute to somebody. No middleman could have come on and represented me. So the trust is built based on the verifiable credential, not on a pre-registration between a relying party and an identity provider. So quite clever, really reusing an existing well-known protocol to implement SSI over OpenID Connect.
Because it's an already known protocol, people are already used to using it. We spoke about familiarity with it before, and really developers still use all the same requests that they used previously with OpenID Connect. There's just additional parameters, so you can actually form a JWT token and pass that as your request. And that JWT is really expressing all the verifiable credentials that you want or you're requesting access to. And that'll be able to be built up and created as a presentation to you. And again, the response with it using the OIDC model, we're really looking at getting a JWT token coming back as your response. So it's techniques that people are already used to using, and with using SIOP, your verifiable presentations will be returned as a claim, just the way any other claim would normally be returned using OIDC. So it should allow developers to quickly learn how to use OpenID Connect to do SSI.
And therefore very easy to implement for developers.
That's right, Chris.
So in summary, this masterclass, just to sum up, we spoke about verifiable credential, them being a data model that describes digital credentials and its presentation and how they can be validated and the crypto proofs behind them. We talked about decentralized identifiers and how they describe endpoints and communication methods and keys that are used between identities. We spoke about two implementations. One is the Hyperledger Aries standard as a toolkit that's based on agents. And we talked about OpenID Connect self-issued provider as an extension to OpenID Connect to support SSI and as Microsoft calls it, decentralized identity. I hope that was informative. We will have a question and answer session as part of the INTEROPen Hackathon to answer any of the questions. So please feel free to use Viber and the relevant forum to post your questions beforehand or post them on the day. And thanks for listening today and for taking the time for listening to this masterclass. Thanks, Rich, for your support on this masterclass. It was great having you and helping pull this together.
Just like to say thanks all, and I hope to see you all at the INTEROPen Staff Access Hackathon on the 21st and 22nd.
Thank you. Bye.